Oi, bom dia.
Eita. Oi, Renata, tudo bem?
Tudo
Tá me
bem, e
ouvindo?
você? Tô te ouvindo. E você?
Ótimo. Tá tudo certo. Beleza. Mesmo esquema de ontem, você entra depois da contagem, tá?
Tá,
Vou ativar aqui, tá? Vou te colocar no backstage. Beleza?
beleza. Tô só resolvendo aqui as coisas. Tudo certo.
Tranquilo. Vamos lá.
Você vai ser pontual, né?
Vai ser pontual. Eu vou tocar o vídeo agora do patrocinador. E aí você entra, como sempre, você entra depois da contagem regressiva.
Tá bom.
Beleza. Até já.
Até já.
Since 1889, we have been writing a story. The story of our enterprise. We found our place in the heart of the Ruhr area, where everything moves relentlessly. This is where we grew up commensurate with our tasks. The story we are writing tells of ideas, but also of gigantic challenges. It tells of creative solutions, of people who united move something and bring it together. But what drives us? Is it our striving for greater flexibility? Is it the fascination of the simple? Or our desire to create something unique? It is the enthusiasm for making multifaceted connections, from small pipe connections to large drive systems. It is the commitment of each employee that makes everything possible. Some things require craftsmanship. Other things run as if on an assembly line. We always keep a cool head in the process, yet also show emotion. We are always on the move for our customers. Often, it is the little things that move the large ones. Often, it is many discussions that leave no questions unanswered. We impart knowledge and learn more every day. We go beyond boundaries. Sometimes we step on the brake so that you can accelerate and bring that which is hidden to the surface. Sometimes we make a lot of noise so that you can have some peace. We are always looking for the new, but hold on to every moment. In this regard, we strive for perfection, yet we always keep our feet on the ground. We like to look back, however, we prefer to move forward. And we do all of this not just in Germany, but throughout the entire world. Our story continues. Keep moving with us as your partner.
Oi, bom dia a todos, bem-vindo de volta, prazer tê-los aqui conosco para a segunda parte do Dia da Engenharia Brasil-Alemanha. Quero agradecer muito a presença de vocês, espero que vocês tenham gostado bastante do dia de ontem, tenham aproveitado muito o conteúdo que a gente trouxe. E quero agradecer também aos nossos patrocinadores e todos que tornaram possível a realização desse evento. Então, aqui a gente tem os patrocinadores Platinum, Bosch, a Kimball, a Siemens e a Vulcan, os patrocinadores Ouro, a BASF, Exact Sales, a Lanxess e a Mercedes-Benz, e também um agradecimento especial aos apoiadores educacionais, a Facens, a Faculdade de Engenharia de Sorocaba e o Instituto Mauá de Tecnologia, além dos apoiadores Startup, a Bônus e a Infinite Foundry. Pessoal, hoje a gente vai focar num tema central, muito importante no nosso entendimento da indústria 4.0, que é o fluxo de informações ao longo das cadeias de valor. E essa ideia que parecia tão abstrata e difícil de executar na prática, ela está se tornando uma realidade e vocês vão poder ver isso agora em breve. Então, a gente tem três temas muito importantes para abordar agora na parte da manhã. Primeiro, a gente vai ouvir do COO do Cluster de Excelência de Internet of Production da Universidade Técnica de Aachen, o Matthias Brockmann, sobre o framework e sobre o estado da arte. Depois, a gente vai conhecer um exemplo interessantíssimo na prática, que é a Volkswagen Industrial Cloud, e quem vai falar para a gente desse tema é o próprio responsável global pela área de produção digital na Volkswagen, o Frank Göhler. E, após isso, a gente vai discutir exatamente como é que esse conteúdo todo se adapta aqui à nossa realidade brasileira, e essa discussão vai ser liderada pela minha colega, vice-presidente na VDI Brasil, a Vera Feba-Maia. Então, assim, a gente pede que durante o Keynote, vocês direcionem suas perguntas pelo chat, a gente vai selecionar algumas para serem abordadas durante o painel. Então, agora, com isso, eu já vou chamar aqui ao palco virtual o COO do Cluster de Excelência de Internet of Production da Universidade Técnica de Aachen, o Matthias Brockmann.
Good afternoon, ladies and gentlemen. Welcome to my presentation. My name is Matthias Brockmann, and it's a very great pleasure for me to present to you today our ideas of the Internet of Production at RWTH Aachen University. As you can see, I'm responsible for something which is called the Cluster of Excellence, and I would just like to give you a short introduction of what that is and what it means for the German science landscape. As you can see on the slide in green, there are universities in Germany which are stated to be elite universities. And the rules of the games work like this, that you need to have at least 2 so-called clusters of excellence. And after that, you can apply to be an elite university. So it's kind of the first league of the Bundesliga in football in Germany, clearly with a focus that in Germany we have decided to have universities with a clear profile of the universities where they are good at. And in Aachen, that is the case for 2.5 clusters, whereas one is a so-called fuel science center and the other one is the Internet of Production, which clearly deals with the digitalization in production, which I will try to inform you about today a little bit more. What you can see also on that slide, and I think that is the most interesting thing for us as researchers in such kind of a project, is the time frame of this objective. You can see that now we have a funding for almost 14 years, so 2 times 7 years. And this group is coming out of a further funding of 12 years. So it's kind of very long-term research, which gives us some very good benefits, which I was trying to show you on this slide. You see that we have over 35 institutions and 200 scientists involved at the location of Aachen. And of course, you maybe also know about the world of science at universities, that in normal times you have project funding for 2 or 3 years, which of course is not long-term or sustainable. And this kind of a project gives us the opportunity to really go into a long-term interdisciplinary collaboration between scientists. So I tend to say sometimes that this cluster of excellence is something like a National Center for Production, which due to the German science system and the boundary conditions is not called like this, but in fact it's something that could be said like this. And you see here that we are the only cluster in the area of production engineering throughout Germany that you saw before. So just one short comment of how is it working in location like Aachen. You could compare it a little bit to the national soccer team of Germany, if you want so. So we have our big clubs that are our institutes and our professors, and we take out, let's say, the players that we need on the certain positions that we need in order to follow our research roadmap for this 14 years. That means also that the staff can change from year to year, and that we can bring new expertise into our cluster if we need them. And that is something which, in my opinion, is a very big benefit within this cluster. And maybe that's also something which I can say from my daily work, that really we have brought it now to some kind of real interdisciplinary, and what is basically new, if you want so, is a collaboration with our computer scientists that are depicted here on the lower right side. I didn't put names, but you see some faces of people who have coined the German world of production in science. You can see Professor Schuh, who is a leading part of the Akatech. You can see Professor Stich, who is one of the inventors of the maturity index Industry 4.0, which is coming from Aachen. You can see Professor Brecher, who is a leading person in the WGP, which is the German Society of Production Engineers. Our structure is similar to that of a big institute or a company. We have a management board that is managing all the activities, and we have research areas called CRDs, cluster research domains, and beyond that there are work streams which are similar to groups. And for me, what is important to mention is that the smallest unit of these clusters are 5 or 6 professors who are working in collaboration. What you can also see on the upper left part of the slide is that we also have advisory boards, which is on the one hand a scientific advisory board, but also an industrial advisory board, and I show the members to you here. It's like this, that these board come together every year. We have sometimes very high-ranked members in this board coming from the executive level of these companies, and we have people from the areas of digitalization in this board. And so once a year we come together and get the advice of this group of companies, and it helps us a lot in order to not do science only for the sake of science, but bringing that also into transfer into the society and into the industry. And that is one major part, and it's also why I'm so happy that I can present to you today. I would just like to give you a small insight. I will not go too deep, but a little bit about the science and the topics that we are looking at in this cluster. And now it was important for me to a little bit describe the organization of our group, because you can see that it's more or less like a roadmap, and you can see that I put it on slide number 1, that in a sense what we are doing here is like a funded roadmap, if you want so, of the RWTH Aachen University, combining many different disciplines. And of course, Internet of Production in this sense is a metaphor for the socio-technical connection of humans, of models, and of machines, of data in the production. I don't know if somebody of you had the chance to be in Aachen. I think that universities are a little bit different in Germany, so you can see it on this slide. We have integrated over 30 laboratories, but if you have a look inside of those laboratories, well, it's more like a small and medium enterprise in terms of up-to-date production machines. We have all kind of different production technologies, from casting, grinding, additive, turning, milling, and so on. We have all that inside of Aachen in our institutes. And that always used to be our big strength in the landscape of Germany, that we have this very high level of specialization in production technology. But on the other hand, this high level of specialization, it can also be a disadvantage if we talk about speed of innovation, and if we talk about exchange of information. So in a way, and I think that is what also German Science Foundation say to us, is that we are like a small model world of the economy, of industries in Germany or other countries, and that's why it's so interesting, our collaboration, because we're facing basically the same problems and challenges that people in reality have. So just to give you an idea of that, so first year, so we're going since 2019, which you saw on this slide. The first thing that we do was to build up a data lake in Aachen. We're doing this with an open source provider. And we have a brownfield like it is in reality. That means some of the laboratories, they have computer numerical control, of course, and they have direct connection of their cyber physical systems to the data lake, whereas other institutes, they need to bring the sensors on the machine in order to get the data to the data lake. And that's exactly the same that we're facing. But in fact, now we're able that all of this very heterogeneous laboratories can bring data into our data lake of Aachen. And if I need to describe our vision or what we are trying to do with this data, very easy. I usually use Google search because it's maybe the most easiest way to understand. So what we're going to want to do with all that data in the lake is, on the one hand, we want to bring it together in a way that is semantically adequate. There's a city called Aach in German, which you can see, which is syntactically very close because it's also the letter AACH, but we mean something totally different. So it's clear we want to put semantics on the data, which is the engineering knowledge in our world. We need context-aware data. That means that people who have searched for the city of Aachen, maybe they want to look at the sites that you can visit in Aachen. And of course, that is also something which is very important in terms of the data that we can get from production, where they are connected to, right? I will go to that a little bit later too. We need data on the right level of aggregation, on the right level of granularity. Also, a small example here about a small excerpt from Wikipedia that you can see with a fact sheet and very short description of what is going on. And what you also know about in Google is that you can have some kind of real-time information. Well, it's not real-time information in the sense that you can fly an airplane with this weather information, but you can decide if you need to take an umbrella or not, right? And that's some kind of, that's a very good metaphor of what we're trying to do in production technology. Real time also is dependent on the domain that we are looking at. In the machine tool, real time, it means in milliseconds. In the design, it could be even one day, and it would be real time, right? And that's, I think, something that is very important also for our world of production. When we talk about data from the sensors and from the cyber physical systems, we're not so much after what I was saying, that we need to put new sensors on the machine, basically, but we need to understand which data or which sensors are already available and how can we make them accessible. And that's on the one hand, of course, semantics, what I was saying, or it means putting the right metadata on the data. Of course, I think that is something, if you look in our laboratories and the engineer is doing an experiment and he's writing a sheet about experimental plan, there are the right metadata on this plan. So that means if we are having a test on a production machine, let it be a turning action, then of course the gravity of the moon has an impact on that physically. But it will be not interesting. Maybe it will be more interesting to measure the temperature in the shop floor. And that's what the engineer or what the expert is doing. He or she know exactly what is the right metadata that we need to put in. That's clearly the challenge number one that we are now doing. Second point is in our university, but also in your companies, there is a lot of knowledge available. And we in engineering, I think we have two sources of knowledge. On the one hand, that are all the standards that we have, that Germany, they like a lot of standardization, but the standardization papers are on paper. So we have no way to access that in some way digital, like you see on the slide of Google. That is the so-called knowledge graph of Google, which gives the opportunity to connect knowledge that is there before in terms of a structure and a common vocabulary, but we don't have that yet. So that's one thing that we're working on. And if you look at this university, clearly we have a lot of doctoral theses and a lot of papers. And here that is the same. If you look normally on PowerPoint slide number one of all our PhD students, they have a lot of expertise in order just to show where the PhD thesis is located at the landscape of science. Alone, if you can say and show where is your point of science in this very high specialized world, you have already bring knowledge to the system, right? And that's what we're doing here. We're having a common standard of ontologies and taxonomies and knowledge graphs in our cluster, and we're seeking for standardized way of putting metadata to the data itself. What we would like to do with the data is something that we call in our concept the digital shadow. So you might also know the term digital twin. Let me say you with a very easy metaphor, and I'm coming back to soccer, sorry, because Germany like it, but I know Brazil people also like football, of course. Maybe you are aware of the game FIFA Soccer. I think you are on PlayStation or Xbox. So if you want, so that is a simulation. It is a model of football. And now there were two streams that we could observe in the past, that the one stream for going into the future is to make that simulation better and better and better, in a way that you can see the faces of the people in the stadium, or you can see the grass and so on and so on. But the second, maybe more interesting development of the simulation was the integration of the live performance of the players into the game, which means that if a player is playing bad in reality, he will also play bad in the game because he's changed the stats live. And that is in a very easy metaphor, of course. what is our opinion of the digital shadow? That means that we need to bring together live data from all the different domains. That is the development of products, that is the manufacturing and production, and that is, of course, the usage of a product, together with the simulation models. And in this sense, the digital twin on this picture can be found on the lower left side. It's the source, right? It's a source of data which, similar like the sun, can, you know, go onto an object and give a shadow. Similar to that, we need to bring parts of the digital twin together with real data in order to find correlations which are useful for production technology. And you can see that here with a very short example, one use case that we're doing, that if, for example, for a milling machine, you can bring data from the location, from the NC data, from the location of the tool, together with data from sensors inside the machines, which are already here, which can be correlated to the force, and bring that together with a simulation of the quality of the things that you're producing. And I think that is the real interesting thing, that if you look at this, let me say, structure with all the circles that you can see here, that's clear, that's a data model. And the interesting thing is the knots between the data model, because within inside these knots, there is hidden the engineering laws, and we do not have so much mass conservation, energy conservation, and so on and so on. All of that is hidden inside of this data model implicitly, and these laws will not change, right? And that's the interesting thing, in my opinion. And that is one kind of example that I was also showing before. It is looking like a normal simulation that you are doing, but in fact, it's a simulation which is connecting a lot of different models from the machine. How is the machine behavior? How is the tool behavior? What is the component doing? And it's predicting if a part goes good or not good within the production. The parts which are red are not good, the green parts are good. But what is done here, and that's the essential point in my opinion, is that the validation is done in every time step according to live data from the machine. That means what normally is done in science is that you build a model, you build this wonderful, colorful picture. Afterwards, you go to the machine, you make your experiments, and you will compare these two pictures and say, oh, that was good, but no, here we have some kind of a problem, and we will go back into simulation and, you know, change the parameters and do that as long as it fits to reality. And that is done in this case in every time step. So that's the first benefit of the digital shadow. But the interesting thing now, when I'm coming back to which kind of data we want to show, it's exactly this data. So it's like refined data with physics that we will not put in our data lake, all data which is produced from the machine. But we want to put in this lake like data which is refined with physical information, and which of course have some kind of, you know, like an ISBN number in books, they can show where is the source data itself. But the interesting thing is data which is prepared like this. What we can do with this data is, of course, on the one hand, different kind of business models. We are a fundamental research project, so we are not so much interested in business model itself. But what you can do, of course, with this is some kind of systematic learning throughout different machines. Like you can see here from this Google Kindergarten, which you all might know, in the sense that if this robot now is able to grab this blue part, all other robots on the world are connected by internet, and they also know how to grab this blue part. That is a very easy, let me say, similarity where we can see already that exchange of data is useful. But now, if I'm coming back to this picture of the digital shadow, if we are able to, you know, bring that data back to physics, then of course also a car could learn from a robot. If we talk about the bearing or other things where the components itself only see force, they see temperature, they see vibration, right? And that will be the same. And the lack that we have is data for validation. And as soon as we are able to bring this data together in a way that it has all the semantics and so on that I was saying, all the data from these cyber physical systems, they transfer to a worldwide lab. They transfer that, in each of these machines, each of that robot is producing data every day, and we can use it for validation of models in order to make our predictions better. And this is summarized in this infrastructure. It's looking a little bit complicated on the first view, I know it, but that is the world of production engineering. And this is also the structure how we are working together. What you can see basically are the three domains in the verticals of production engineering: the development, the manufacturing and production, and the use of the products. And if you look at the horizontals, then in the lower blue part, you can see this proprietary software that engineers in the different domains are working with. This data is proprietary. It is not exchangeable right now. It is maybe, for example, from CAD to CAM. But if we talk about, for example, connect data from the client with production data or design data, in my opinion, we are far away from that. So that's clearly what we want to do. And I explained to you this idea of the digital shadow. And this depicts it a little bit. The core of the research that we're doing is in this green marked area of this infrastructure. That means that we are developing a middleware, kind of a universal language translator. It's like a PDF format for this data if you want, so for exchange with semantics, and the development of these digital shadows for different kind of production domains. What we can do with this afterwards is, in my opinion, not only the optimization of the production processes and the domains itself, but if we look at the development of products nowadays, in my opinion, I think there is a lot of potential to be faster. I'm personally coming from an area of aero engines, from turbo machinery. I was working a long time for a turbo machinery company based in Britain. And you know that similar to the car manufacturing, of course, that is a certified product. That means that all different kind of steps need to be certified. And I'm aware of the fact that it cannot be the same like in software, but I think that we can do more steps to a highly iterative innovation if we just accept that we can have this data before. So in a sense that, for example, if the aerodynamic design demands a radius of the part because there were calculations about the flow, which is very, 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 very thin, and production cannot even produce it, and you need to start all that process from the beginning, it would have been better to have this information before. Right? And of course, at the end of the day, also the question of the performance of the part, or was this part over-engineered itself? Or did production produce it in a way how design wanted to have it? And do we really use it afterwards in the usage of a part? So that's, I think, the major point, that these data from usage, from production, and from development need to come together. And afterwards, I think that this can be really a milestone that can be really a paradigm change for engineering and engineering processes itself. Thank you very much for your attention.
Obrigada, Matias, parabéns pelo excelente trabalho desenvolvido pelo seu cluster. E agora a gente tem a oportunidade de conhecer um exemplo já implementado na prática, que é o exemplo da Volkswagen Industrial Cloud. E com isso eu convido ao palco virtual o Head de Digital Production da Volkswagen, o Frank Göller, que se juntará também na sequência ao nosso painel de discussão, liderado pela Vera Feba-Maia. Só queria lembrar para vocês que a Vera vai conduzir esse debate em inglês, mas fiquem à vontade para colocarem suas perguntas em português, e nós vamos selecionar algumas para responder ao longo do debate.
Hello everybody, my name is Frank Göller. I'm from Volkswagen Group, Germany, working for Volkswagen Group in the function for digital production. That means I'm responsible for the overall coordination and steering of the digital transformation in production and logistics. And today I have the pleasure to explain you a bit more in detail what we are doing to transform our processes all around the world with all our brands and our factories. Please, the next page. Short introduction to Volkswagen. I think company is pretty known. So we have 12 brands. We have over 124 factories all around the world. Looking on the map here, you can see how they are distributed. Last year was a quite successful year with over 250 billion euros in revenues. We sold around 11 million cars and created an operating result of 17 billion euros. This year, unfortunately, we know Corona is hitting us all very hard, so the numbers will be different, but let's hope that we all can recover. But now to the topic, digital transformation. I have brought 7 topics to you. I want to talk about a bit the vision, how we translate the vision into our ecosystem, how we govern it, so what is the organization behind that, some key learnings behind those activities in our journey. We started 2 years ago. Then I want to tell you a bit about our design principle for the platform, and also how we do the plant rollout and the scaling concept behind that. And finally, I want to explain you a bit more how we want to engage and invite external partners also to join in our transformational effort. This next page, please. So, you know, digital transformation has several disruptive topics in front of it. It's the autonomous driving, the electronification, smart and diverse mobility, and also the connectivity and IoT topics will hit us in each industry. And for this challenges, we have defined a staircase, what we want to go through to really create and shape our transformation journey. And here you see the steps, beginning with the connectivity of the real world into the IT world, then creating information out of the interfaces, learning out of that information, what is happening in the past, and then coming to the Champions League, so to say, using artificial intelligence with predictive systems. And finally, a future dream is then to have really autonomous systems. So this is the whole thinking behind that, and this brings us to a vision. And this vision is that we come together with strong industrial partners like Amazon Web Services and Siemens, and we want to create an open community for the automotive industry and also for the manufacturing industry beyond current IT architectures, based on a cloud architecture to enable all the processes and value chain activities to act in a digital production and digital logistics. The idea behind that is, please go to the next page. The idea behind that is that we have a two-folded system, and now waiting for the next page. Thank you. And as a first step, we are starting internally within our value creation activities that we set up a so-called digital production platform. The basic idea of the digital production platform is that we want to combine and connect the data of all machinery in our network to really create new standards how to run the machines and how to learn from the existing data of the machines. This will create a new infrastructure within the Volkswagen world based on AWS technology and basics and standards elements combined with Volkswagen customized elements and topics. And this is the core idea that we improve this new architecture, our cost performance in our factories by something like 30% until 2025. And we say if we have created this kind of system to really work in a new way with our data and with our processes, why shouldn't we also give other industry partners the chance to work together with the same infrastructure in their own processes? So that means we have an internal view and an external view to really have a cooperation with external partners as well to make this really a big cloud activity to learn from each other and to create a new industry standard along the value creation chain in manufacturing. And having this idea, we said we have also to think about our architecture within the Volkswagen world. And you know, Volkswagen is a company 100 years old in some locations. And this is also the topic how our IT structure has grown. We have in the older factories monolithic and very old and I want to say complex systems. This means that some of our main systems are over 2 or sometimes 3 decades old, and maintenance activities and the complexity in those systems is really high. And we have decided together with our partner AWS that this has to be brought into a new architecture where we think about a layered architecture. And this layered architecture is simplified to say in 3 levels defined. The first level is the connectivity level where we link all our physical processes beginning from the inbound up to the outbound process to a common platform based on AWS standards, but also based on Volkswagen customized standards. And this is, so to say, the backbone, the spine of our architecture with standardized interfaces into a microservice world. That means having this middle layer created, we then invite our factories, our brands to define and to develop own use cases with a standardized interface to improve, for example, efficiency activities in paint shop or quality assurance, prediction in the assembly, and then to share those activities and those use cases across all brands. So that's the core idea, and we are pretty sure and have also experienced that this is really delivering new synergies and new levers to improve our performance in quality and cost. If we go to the next page, you will see that the core idea is really to create a strong platform idea with AWS and with Volkswagen. Here in this picture, you do not see Siemens, but Siemens also plays a very important role because Siemens is our strong expert and partner for the connectivity part because they know all the details, how to connect the machinery, how to connect the processes to the spine of our platform. And based on that spine, as I said, we will create several use cases along the value creation chain we can then offer to our brands and later in the industrial cloud also to external partners. I can give you one example for these use cases. If we jump to the next page, there's a very new case based on the technology of industrial computer vision. That's a very hot topic, so to say. This is a new technology to work with camera systems and to improve quality or also precision processes within the production. In this case here, we have a process of labeling. This process was created with Porsche in Germany. The current situation was that an assembly person has to check manually over 1,300 labels in the car. So it's not in one car, but across the different countries. And they had to check, are the labels on the right position? Is the right content on the label? Is the right language on the label? And this costs a lot of time. And here we created a simple computer vision application on a mobile device. You only take a photo of the label, and the light artificial intelligence in the background is checking all the content and all the languages and gives immediately, so to call in real time, a signal if this label is positioned right to this car or not right. And then the whole checking process is a lot of quicker and preciser, because failures are not made if other data are correct behind in the application. This sounds very simple, but the tricky thing behind that is the architecture. If we jump to the next page, you will see that there are several details in the programming and software. I don't want to bother you with these details, but for us, the very important thing is that we can use a lot of standardized elements out of the AWS toolbox. This means we are creating individual customized solution based on existing standardized Lego blocks or building blocks, so to say, from AWS, and a bit later, if we are further in the development, also from our own programmed elements. And this makes it so simple to really create new use cases and to create new solutions for our processes in the factories. So that's the main idea, having as much standardized elements to be combined as possible. I have mentioned it that we have a strong partnership between Volkswagen, Siemens, and AWS. And here we are really gaining from each positive aspects and knowledge from these partners. As I said before, Siemens is a very strong partner in connecting machinery and bringing the machine data to the cloud. AWS has a huge library of standard elements. I think at the moment it's something like 240 elements we can use and leverage to create our backbone of the architecture. And Volkswagen is bringing all the manufacturing expertise and also the customization practice and expertise to create the real manufacturing cases. Because it's not only creating a new architecture in the IT, but it's also to make us as a partnership stronger for future manufacturing corporations. And if we jump one page further, you also see then the innovation across this process that I said. It's not only the technology we are thinking about, it's also the people and the processes, especially if we talk about AWS. We have a very close cooperation. We have created a new office together in Berlin as a first step to really learn from each other how to work together, and also to adapt from AWS the new working standards. And you see here on the right side some of our, I want to say, new thinking, what we have brought together, like standardized data layers we are creating. We have common interfaces defined and also new microservices to be scaled across our IT landscape. This is something that is really helping us to create this new IT architecture, as mentioned before. What are the first achievements? Kind of snapshot you can see here from April this year. As I mentioned in the beginning, Corona crisis hit us also very hard in this program, but we managed to continue the rollout and the activities. So Last year, we have rolled out a DPP platform in 3 factories in Europe. This year, we had a plan for 15 factories for further rollouts, and the good story is that we managed to onboard these 15 factories across Europe and also some in US. That means we also have a plan in place to connect all 124 factories. End of 2021, there's a plan then to have 45 factories in the network of the DPP. And we have also created a first set of initial applications. This set is has 15 cases now in the offering. That means 15 cases are developed and are in rollout to the factories as well. These are the cases like the labeling you have seen, but also bigger cases like welding spot quality prediction or some failure identification in the final quality check of the assembly line. That is not a very huge step, but there are more than 100 cases in a waiting position we want to develop within the next 2 to 3 years, that we can really fill the DPP with these applications for all our factories. In total, we have 220 people working on this program at the moment. And as I mentioned it before, our overall target is to increase our performance in production by 30%. There's also a saving number. You see it here. It's something like 200 million euro we want to save until 2025. And this is where the first slice we are focusing. And we are sure that there is much more on saving potential behind all these activities. That is something like a short status point after the implementation until now. How do we run that whole program? I have mentioned it that we also learn a lot from AWS, and we have learned that we create several independent teams. If you go to the next page, only to see that we have use case teams and use case communities where we bundle expertise. For example, we have a use case community for energy management, for example, the computer vision activities, or also automotive specific topic for the road test predictor, where we want to try to reduce the necessity of road tests. And these communities are growing, and we are working with a AWS specific approach. They call it pizza teams. So these teams are not bigger than 10 people. They are cross-functional set and typically co-located in one office and working closely together. And they also have a kind of sprint mentality, you know, the sprint logic to define weekly targets or bi-weekly targets to create progress and then to measure against the created activities. So that's a very helpful topic because our AWS is also a teacher for us here. Some learning topics we also have extracted until now, because the journey is now 2 years old, and we know the next 5 years we have to go for. But it's always important to think about the key learnings year by year, and I want to share some key learnings with you here. And the very, very important thing, and you know that, is that we need a very strong CIO support. So if we don't have the board on our side, if they don't help communicating and help creating the budgets for this activity, the whole thing will fail. That means stakeholder work and stakeholder cooperation is very, very important. Then it's extremely important to really understand what is the use for the production and logistic guys. We cannot sit down in our offices and think about fancy cases. but we have really to talk to our production and logistic colleagues and really to understand what is really driving their need and what is really necessary for them to improve their processes. We have a use case proof of concept procedure defined. That means we are very quick in creating minimal viable products. You know this word, so that means not planning too much, not creating too much paper, but really starting as quick as possible with a real pilot, with a real minimal viable product, and try to make it work to see if this is delivering the impact we are planning for. And also, as I mentioned before, the cross-functional work with the teams, with the IT, with the production, with the logistics is very important. And also, we have integrated very, very early our workers' council, but because very often we are working closely within the workplaces of our colleagues in the lines in production. The empowerment to make your own decisions, not to wait until a board member is giving the decision. So have very short and agile decision routines is important to create quick use cases and quick applications. And finally, we have always to measure our progress and to identify critical processes or critical topics so that we can escalate very quick and that we can make also quick decisions here. That is a key learning, or that are the key learnings after 2 years of our journey. And maybe the third point is that we also do very often this kind of lesson learns workshop to really reflect and understand what we can improve. That brings me now to some ideas or some thoughts behind the platform thinking. And very simple, and I mentioned it before, it's not the spine I have talked about. It's not the standard element AWS is offering us, or it's not a connectivity Siemens is creating together with us. That's the enabler that we can work with our process. The main important thing is that we really create use cases and enable our organization to develop their own use cases and to make them scalable. Because the platform without the use cases will not help us any more or any further. And therefore, we have to think always creating the technology, the platform, but also enabling the organization to create use cases. What does this mean? I will try to explain a bit more in detail. Sorry for this detailed page, but as I said, we have this layered approach. And here it's important to understand what is the plant infrastructure, what is the existing machinery and the existing plant IT, and then we have to link that together to our platform, what we have created with the standards. So do we apply advanced analytics? Do we apply the cloud structures? Do we have a security concept for the data and the data rights, because we work across the world, in Europe, in Americas, and in Asia? And that is something we have to clarify with our partners, and we have to give them very clear roles. And if we jump to the next page, and I will not go through all the details, but I only want to explain that this main structure is really important to think through it, beginning with the OT IT gateway up to the edge gateway, and then into the DPP application and the landing zone in each factory we are creating. If you don't know the word landing zone, that is very important for us, because this is, so to say, the platform in each factory where the factory can then customize and adapt the individual cases in each factory. So that means we have also created a quick starter kit that enables the factories to really create their own landing zone with our help. And that is the first rollout activity we are driving, so that there's really the individual or customized technology in the factory to allow them to work with the DPP in their own manner with their own cases. As I said, that's the basic structure we have created there. And now coming slowly to the end, The plant rollout is very important for us because, as I have mentioned it, we have 124 factories, bigger factories, smaller factories, and we really want to onboard them all and have a good scaling model behind that. And here we have asked us 3 questions we can see on the next page. The thing is, how do we create or set up the overarching operating model to really invite all the individual plants? As I said, we have plants 100 years old and we have plants some 10 years old, and that is different. Then also we have to ensure that the transformation from the old structure, from the old enterprise into the new platform is assured. And finally, the factories will ask for benefits, because at the end they have to pay the cloud consumption, they have to pay the portion of the application development, and the plants will only use the DPP and the applications if there are benefits. And we are talking about benefits not within 5 years, but in 2 years. So we also have we want to create a very short amortization time. Behind that planning and discussion, we create for sure rollout plans, and this is only an example how this could look like. And you see this, that's an example for 1 year, and it's really not a long distance race to onboard one plant. So it's something like 1 quarter or 2 quarters within a year to really create the onboarding process in the factory, and then we can quarter by quarter establish the use cases in the factories. And the good thing is that this is driven in the beginning centrally by the group and then AWS, but after 1 or 2 use cases, the IT teams and the onboarding teams in the factories, they have learned how to onboard the factories, how to the application, and they have learned how to roll it out, how to make the connectivity broader in the factory. And we are keen to see that after 6 to 9 months, the factories are really able to continue their own race. And at end of this year or beginning of next year, we are also able to offer a kind of marketplace like an app store, and then factories can also make a first check which applications are available in this app store or marketplace, and then they can also download them and try to establish those cases on their own in the factory. Another important element, if we jump to the next page, is that we train from the beginning with the people, that we make an enablement. I have mentioned the Quick Starter Kit. That is a very standardized kit on the technology side, how to work with the AWS elements and also with the Siemens connectivity elements. And we also have to be sure and to assure that the technical enablement in the architecture is working. So we are creating more or less new IT architecture with new logics of interaction and interfaces. And this must be also anchored in our IT departments in the factories, and therefore training and enablement is a quite important topic. And last but not least, we have the starter packages defined, and here you see 6 elements we have really thought through to help the factories in the best manner, so that we really have role-specific trainings in place. We also have a kind of sandbox accounts for experimentation, so that they can do tryouts and have a kind of risk-free testing trail. We have also connectivity blueprints that we can quick connect the machines and the processes. Very first tools for quick data analysis is available. So it's not specifically customized, but it's like Tableau, like other topics we can then use to do very first data analysis in the factories. Very important thing is for the plants, as I mentioned it before, the cost transparency, that they really see which costs are coming up to me, up on my factory. And also, as I mentioned it, we will have a shared access to the DPP services and use cases in a kind of marketplace. This is not yet established. As I said, this is a plan to work on that, but we are keen that next year will be we will have several of those topics and really fully available. And now, last but not least, give me a short outlook how we want to share this experience also with the external partners. As I mentioned it, if we jump to the next page, we are creating also the so-called industrial cloud ecosystem. And we want to create that because we know if we invite more partners, more industry partners and manufacturers, we will have more good ideas and open innovation. Because if I invite an equipment supplier of automotive industry to think about applications to improve processes, this will help everyone in this marketplace, and therefore we are asking for partners joining and thinking about good ideas to create an application. This will also help the scaling because this will create a new standard, and if the standard is more often used, the scalability is better. And last but not least, if we have our suppliers integrated, if we have so for the parts suppliers and also for the equipment suppliers, that the integration of our value chain will continue, will have a good progress, and it makes us even better and stronger working in the whole supply chain. And how this look like, I have brought you a picture here. That means we will have in the center this marketplace where we offer several microservices, several applications, and as a partner in the industrial cloud, every company can offer applications, but also buy applications and use them. The whole thing is then established on the common platform based on the AWS technology and the connectivity topics from Siemens, and the community itself will establish open innovation philosophy to really exchange ideas, to exchange applications, and to have a vivid communication across industries in manufacturing. So that's the core idea behind the industrial cloud, and to bring our digital production platform to the external industries. And if we jump to the last page, you can see that we have already started with that topic in the industrial cloud, and partners like ABB, Dürr, Grob, Vago, Celonis, software providers in industry, Celonis, Navision, and also system integrators like MHP and Bearing Point are already partners in the industrial cloud, and we are proud to have them on board, and we will definitely develop our system further. And if you are interested, please let me know, and I'm happy to hear questions or comments from your side. Thanks a lot, and have a good discussion.
Let's be honest, the world has changed a lot over the past few years.